Good day, everyone. Welcome to Direct Stars. Our subject for today is physics, while our topic is static electricity. Aim of today's lesson is for you to understand the concept of static electricity, and today's objective is for you to know what is static electricity and demonstrate forces between charges. So now, what is static electricity? At first, you need to understand what static is. Static means when an object is at rest, when it's not moving. That is static, stagnant. Okay. So now when we say static electricity, that means when electricity is not moving. Okay, a stagnant electricity. So how does it work? Static electricity refers to the buildup of electric charge on objects. While this electric charge typically caused by friction or contact between different materials. So static electricity works when there is contact or friction between different materials. And these different materials might be insulators or conductors. So these buildups can lead to attractive or repulsive forces between objects. So what is an insulator and conductor? So insulators are materials that doesn't conduct electricity, that doesn't allow the flow of charge, which is electric charge. While conductors are the materials that can conduct electricity, that allows the free flow of charges. So static electricity, on the other hand, is caused by buildup of stationary charge on a surface. These occur on the surface of insulators. So let me just say this is insulators 1 and this is insulator 2. So at this point, they have different charges there. The positive charge is here, the negative charge is here, the positive charge is here, the negative charge is here. Yeah. Without contact, no movement of charge. Okay. But when there is contact between them, so this contact, at this contact, the buildup of this contact is when this charge flow. At that point, that is static electricity. So this is 1 here, and this is 2. We have positive, we have positive, we have negative, we have negative. Now, through friction, okay? Now, at that point of friction, at that point, there is little flow of charge between the positive to the negative, to the negative to the positive. How does it work? It works by when they both have the same charge, which is same charge, then we have repulsion. But when they have different charge, then there will be attraction. Some examples of static electricity are rubbing a balloon and sticking it to a wall. At that point, the balloon is an insulator, and I want to let you know that insulator materials, they have more positive charge than negative charge. That is why they doesn't allow the flow of electric charge. Why? Because they have more positive charge than the negative charge. So at this point, rubbing a balloon and sticking it to a wall. Rubbing a balloon it has more positive charge because it's an insulating materials, while the wall also has an evenly distributed charge, positive and negative, evening. But at the point that you are rubbing this balloon to that wall, at that point, the wall will have more negative charge. Why? Because the rubbing the balloon from positive with a little negative charge will allow a little flow of charge. And that is how static electricity works. Because it's just the buildup of the electric charge on those objects before friction and contact. So when friction and contact occur, then there will be a static electricity. We have another example here. Air sticking up after combing it with a plastic comb or going down. Now, this is how it works. The comb there is insulating material, while your air is also insulating material. But at the point when there's force, where there's little contact, okay, a friction between them, that's when you can see there will be a little attraction. After you comb your air, you see a little attraction between the comb and the air. Yes, because at that point, with friction, okay, and there is contact between them, they are exchanging the positive and negative charge between them. Okay, so now let's demonstrate forces between charge. Let me explain that. Remember, all objects are initially electrically neutral. Why? All objects have the same positive charge and negative charge at first. That is what we call evenly distributed. Charge are evenly distributed. But as time goes on, There are some objects that has most positive charge than negative charge. Why? That because of the surrounding, because of the environment, the weather, because of the electromagnetic waves and everything, because of radiation. Yes, there are some materials that needs to give out their negative charge so that the positive charge will be more than the negative charge. That's the insulating materials. While there are some materials that need to give out their negative charge, okay, so that their negative charge, they need to give out the positive charge so their negative charge will be more than the positive charge. Those are conductors. So when a charged objects are brought near to each other, forces of attraction or repulsion occur. Forces of attraction occur when there are different charge, positive and negative, there's force of attraction. But when they are the same charge, that is positive and positive, I mean, when they have equal, like they have the same equal positive charge, positive charge in one material is more, and this positive charge in other materials are also more. So at that point, they have both positive and positive. They will be repulsion force there. But if negative charge in first material is much, while the negative charge in second materials are also much, then that is when there will be the same repulsion, which is negative, negative. But when there is more positive charge in first materials here, and we have more negative charge in second materials here. So at this point, this is what we call attraction. So there will be force of attraction between them. So, and I've explained one, sticking a balloon to the wall. Rubbing a balloon on that winning jumper is the positive charge, but the wall itself is evenly distributed. But at the point where there is contact and friction, then a little flow of charge will occur there. So let me give you more example. And the first one here is buildup of electrons. Now, in the first place, you can see sometimes you can have little shock when you touch the door handle. Do you know why? Because at the point, you might be positively charged and the door is negatively charged. So at that little spark, there will be a little shock then. But if both of you are in the same charge, then there won't be any shock. Now, same thing happens to when you touch, like there's a contact between you and another person, and you feel that little shock. That is what we call static electricity. At that point, is either one of you is having high positive charge while the other is having high negative charge. That is why the little spark occur. So I want you to take note of this. Same charge repel, opposite charge attract. So that will be the end of today's class, and please don't forget to click the subscribe button. We'll meet in our next class. Bye.